Hi, I'm Reverend Greg and I welcome you to this video in the tutorial series Shaders for Hobby Programmers. This time we'll look into duotoning. As always, a short disclaimer, this tutorial series is mainly for hobby programmers who struggle with understanding shaders. I'm not a professional programmer and I'm not very good at maths, so if you see any mistake in my video or see a better way to solve a problem, please add a comment so everyone can learn from you. For the few viewers who wonder what duotoning is, it's a method in black and white photo processing where the lights and the darks are not necessarily black and white. The most known duotone probably is the sepia tone, where the white is replaced with a brown yellowish light color. First we'll create a simple duotone shader ranging from black to another color instead of white, like the mentioned sepia toning. Let's create a new shader and call it Shader Duotone Simple, and close the vertex shader. In the fragment shader we convert the colors just to a grayscale for now. I want to do this step by step for educational reasons. This is a tutorial series after all, and more about understanding shaders than just getting the code for a duotone shader done. So I split the GLFrag color line as always and used the dot product and the NTSC conversion vector to create a grayscale image. Base col is texture2d gm base texture vv text code. Float gray is dot of base col.rgb and the NTSC vector 0.299, 0.587 and 0.114. And GLFrag color is VV color times vec4, vec3, gray, base col A. Then duplicate the template module in the base project or create a new object if you're not using the base project and call it Object Duotone Simple and place it in the test room. In the create event I quickly add the usual things like info text, sprite, and shader. And in draw event, I'll just make sure the shader is set and the sprite gets drawn and run the program. Okay, so this is the image desaturated. I'll make a screenshot to compare with later. Now back to draw event. I'd like to use the vertex color now to get a duotone, so let's comment out the draw sprite function and use draw sprite ext function instead. As color, set the sepia-like color AAD4FF and run the program again. It's definitely a duotone already, and it kinda looks like sepia, but when comparing with the grayscale image from before, we easily notice it's a bit darker. That's because the vertex color is multiplied into the texture color and will always lower the luminance unless the vertex color is white. Before moving on from here, make a copy of this shader and the object. We'll use those copies later. Now in create event, we'll add uniforms for the second color the way we learned before. I'll show other ways, and in this case better ways, afterwards. We need a uniform for each color channel, so I create 3 handlers and uniforms like so. uDuoCol R is shader get uniform shader duocol R, and the same with G and B. And let's also set up some color values already to get something like a sepia tone, although I'm not sure how exact those values are. duocol R is 1.2, duocol G is 1, and duocol B is 0.8. Notice that the red color value exceeds 1 and the blue channel compensates that to at least somehow keep the average luminance of the image. Now in draw event we return to using the draw sprite function. We now need to pass the uniforms into the shader. Shader set uniform F, uDuocol R, duocol R, and the same again for G and B. And in the fragment shader we need to define the uniforms. uniform float duocall R, uniform float duocall G, and uniform float duocall B. Now we create a color from those three uniforms. Vec3 duocall is vec3 of duocall R, G, and B. And we multiply that duocall with the grayscale in the GLFrag color line. Now here's something very interesting about colors in the fragment shader. If you think about that GLFrag color line for a second, we multiply the duocall R, which is 1.2, with the luminance of the pixel color. Now that luminance of the pixel color can be anything from 0 to 1. And if it's 1 and we multiply it by duocall R, the red channel of the new color is 1.2 and thus exceeding the range of colors in RGB, which would be 0 to 1. The lesson to be learned is this. Colors we calculate within the shader can exceed the RGB range of 0 to 1 because GLSL just handles them as any other vector. GLSL doesn't even recognize them as colors. In the end of the fragment shader, the output vec4 GLFrag color will automatically clamp each of its components to 0 and 1, so we don't even need to clamp the output ourselves. But now let's run the program again and compare the images so far. As you can see, this looks way better. It looks like the average luminance is about the same as it was in the grayscale image, although of course not exactly the same. The shader is already working as I wanted to, but now I want to show a better way to pass in those three uniforms. So let's go back to the create event. Here I leave the values as they are for now, but I want to use just one uniform. I'll call the handler uDuocall and the uniform duocall. In draw event, I'll only need one line to set the uniform now. As you can see in the function's description at the bottom of the window, we can pass multiple floats to the shader. So we change the handler to uDuocall and pass the three values like so. Shader set uniform F, uDuocall, duocall R, duocall G, duocall B. This will pass three floats to one uniform. So inside the fragment shader we need to make some change as well. We only need one uniform now. I'll just call it uDuocall, and since we're passing three values into it, we define it as a vec3 instead of a float. We could also define it as an array of floats, but we'll come to that in another tutorial. Now we can just remove the line where we created the vec3 from the three previous uniforms and run the program again. As you can see, it's unchanged, but it was a bit simpler to do. And now an additional change, back to the create event. Let's get rid of the three variables here and replace them with just one array with the same values and call that array duocall. So duocall equals 1.2, 1.0, 0.8. If you're using GMS1, by the way, you'll need to write that in three lines like so. Duocall 0 is 1.2, duocall 1 is 1, and duocall 2 is 0.8. And in draw event, we change the setter to shader set uniform F array and pass in the array we created. Now we won't need to change the fragment shader anymore, so let's just run this again. And it's still unchanged. It works. Now the next and last tweak is just for demonstration purposes. In the description you'll find a download link to this script uShift-RGB. I'll use this script to shift the hue of the color array depending on global.slider1 of my base project. If you're not using the base project, just create a tween from 0 to 1. Now let's run the program again and test that slider. I wanted to show this simply because I think most people think of sepia toning when hearing duotoning, but duotoning is not restricted to sepia tones, and it wasn't even in analog photography. Now I might upset some viewers, but I think there's another really nice way to do this simple duotone shader without using a uniform. I showed this first version anyways because it was a good opportunity to gradually explain how we can pass an array from GMS to a uniform vector in GLSL, and to explain that the color channels don't need to be between 0 and 1 while calculating, and only get clamped at the end of the fragment shader. The shader program of the second version will not be simpler, nor will it necessarily be faster to run, but since we won't need a uniform, it's simpler to set it up in GMS. Now the whole idea about this version 2 is this. A few minutes ago we tried to create the duotone effect by just using the drawSpriteText function to set the light tone of our duotone shader, and we realized the image gets darkened. So I just dismissed that idea completely and claimed we need a uniform to pass in the color, because drawSpriteText cannot pass in a color with channel values above 1. And as far as I know, that's true. If anyone here knows better, please leave a comment. But also we by now know that a color inside the shader is not recognized as color, it's just a vector. This means we can increase the luminance of VV color above 1 inside the vertex shader and pass it to the fragment shader. So here's the second version of the simple duotone shader. Earlier, right after we tested duotoning with drawSpriteText, I told you to make a copy of the shader and the object. Now just add a v2 for version 2 to their names and place the object in the test room. Let's have a quick look at the create and draw event. As you can see, in this version we did not yet set up the uniforms, but we need to now set the shader to version 2. If we run the program now, we're back to that dark and sepia toning. Now it's time to increase the luminance of VV color. We could do that in the fragment shader, but then that code would run once per fragment or per pixel. Instead we now change something in the vertex shader, for the first time if I remember correctly. It makes sense too, we want to change the vertex color, so doing that in the vertex shader, which is only run 4 times per sprite, seems logic. Anyways, let's open the vertex shader and delete the VV color is in color line. We'll do that a bit differently in a second. Now we need to figure out how and by how much to increase the luminance. The how first. Since VV color can be any color we set in drawSpriteText, we can't just multiply by a constant. This means we need to somehow factor in the luminance of the vertex color. And we did that many times in the fragment shader already. This time we just do it with in color instead of the texture color. So float gray is dot of in color.rgb and the NTSC vec3 0.299, 0.587 and 0.114. Now about the by how much. That's pretty simple too. We need to multiply by 1 divided by gray. Since gray is between 0 and 1, this will increase the vertex color's luminance. So it's vvcolor.rgb is incolor.rgb times 1 divided by gray, or simpler, vvcolor.rgb is incolor.rgb divided by gray. But we mustn't forget the alpha channel. So it's in the end going to be vvcolor is vec4 incolor.rgb divided by gray incolor.j. Now let's finally run this again and compare the results to what we had earlier. These are the previous screenshots, and as you can see, the result of our version 2 is pretty much the same as in version 1, and this without using a uniform. One important thought though. We're dividing by luminance, and the luminance might be 0 if the vertex color is black, meaning if we set C black in our drawSpriteText function. Now of course it doesn't make sense at all to use the vertex color black in this duotone shader, but if you want to know how badly the shader crashes when it hits a division by 0, then just set C black, run the program and see for yourself. But now to the second type of duotone shader I wanted to show. Let's create a new shader again and call it shader Duotone Stylized and close the vertex shader. Then duplicate the template module again or create a new object and call it object Duotone Stylized and place it in the test room. In create event again, I'll just set up the standard stuff, info text, sprite, and shader. Now we set up two uniforms. The handler uDuoCallLight for the uniform DuoCallLight, and the handler uDuoCallDark for the uniform DuoCallDark. And also two arrays. DuoCallLight is 1.2, 1.2, 0.6, and DuoCallDark is 0.1, minus 0.4, and 0.3. You can pick other values if you want. For now, just make sure that the dark color actually is dark and the light color actually is light. In draw event, I'll create two local vars called dark and light, and just use the U-shift script from before, so our sliders 1 and 2 can change the hue of both colors, or create some tweens if you're not using the base project. So var light is script U-shift RGB DuoCallLight global.slider1, and var dark is script U-shift RGB DuoCallDark global.slider2. After setting the shader, I'll pass the uniforms as float arrays as we did in the previous shader, but this time for our light color and dark color. Inside the fragment shader, I defined the two uniforms as vec3, uniform vec3 DuoCallLight and uniform vec3 DuoCallDark. Inside the main function, I split up the glFrag color line again. I'll get the gray value of the texture color as we've seen so many times by now. Float gray is dot of base color.rgb and the NTSC vec3 0.299, 0.587, 0.114. And create a new vec3 outcall and mix DuoCallDark with DuoCallLight by the mix amount of gray. This means the darker the fragment is, the more of the dark color shows, and the lighter the fragment is, the more of the light color shows. Now all we need to do is set glFrag color to a vec4 with the outcall and basecall.a. And let's run the program again. Now you can see how the dark color affects the dark areas and the light color affects the light areas, which gives an interesting effect. But I want to add one last feature. I really want to crush the dynamic range of the image. I want to give both colors their breathing space, so the goal is that the dark color shows unchanged in a specific range of darks. Like in example, every gray value of 0.2 or less shall be the dark color, and every gray value above 0.8 shall be the light color. So back to the create event and add a new uniform. I create the handler uCrush for the uniform crush. In draw event, I pass the uniform as a float using the global slider 3 and multiplying by 0.5. Because at 0.5 we've reached the maximum crush level. Every gray value below 0.5 will become the dark color, and every gray value above 0.5 will become the light color. If you're not using the base project, just set a constant somewhere between 0 and 0.5. In the fragment shader, we need to define the new uniform float crush. And after the line where we got the gray value, we now crush it. Now it's time to explain another really important function in GLSL, smoothstep. Smoothstep takes 3 arguments, value 1, value 2, and a value to compare against those 2 first values. Now what smoothstep does is this. If the value to compare is lower or equal to value 1, smoothstep returns 0. If the value to compare is higher than or equal to value 2, smoothstep returns 1. And if the value to compare is in between, smoothstep returns an interpolated value between 0 and 1. The interpolation is not linear though, it's more like a cubic ease in, ease out tween to get a really smooth transition from 0 to 1. So in our case, if the gray value is lower than the crush threshold, we want the gray value to become 0. If the gray value is above 1 minus the crush threshold, we want the gray value to become 1. And for every gray value between crush and 1 minus crush, we want the gray value to be an interpolated value between 0 and 1. So we write gray is smoothstep, crush, 1 minus crush, gray. And this now changes how the mix function mixes colors because gray is the mix amount. But let's just run the program and see what happens. With slider 3 we can now really crush the dynamic range and get some interesting effects. If you want to play around a bit, try it on an available light image or a photo of a city at night. Now I want to show one thing I mentioned in an earlier video. With this shade I can hardly imagine that I'll ever need the vertex color at all. So let me show you that this shader works without the attribute inColor and the varying vec4 vColor. Let's comment out every mention of those two variables and you'll see it still works. So we remove inColor and the varying from the vertex shader, and we'll remove the varying from the fragment shader and run the program again. And there you go. So if you think you won't need the vertex color, it's absolutely safe to just remove it completely from both shaders. Functions like drawSpriteX won't tint the image anymore, but they still will run without throwing an error. If you want to keep working on this shader, try to make a tritone effect where the midtones get a third color, or even a quadtone effect, which I imagine could look extremely nice actually. And for everyone who didn't bother to create a division by 0 earlier when I dared you to, or for everyone who got scared by the way I phrased it, a division by 0 in GLSL always just returns 0. Nothing else happens. So that's it. I hope you learned quite a bit more about shaders and colors and enjoyed this video. If you want to stay updated when I post a new video, just subscribe and click the bell icon to get notifications. As mentioned in the intro video, I'm not monetizing this channel, so the amount of subscribers isn't important to me, aside from the ego boosting effect every subscription and thumbs up brings with it. In the next video, we'll look at something kind of similar, a Sin City effect shader. Until next time.